All right, we're back. Number 16. So if I look at number 16 here, it says find the absolute minimum and maximum of the graph from 1 to 3. So when you ask for the absolute maximum or minimum, all you're asked for is the y-coordinate, the greatest and the least, or if it exists at all. So let's look at each one at itself. So number 16, look at that. So the absolute minimum for number 16 would be the y-coordinate at the bottom. That answer would be 0. The absolute maximum would be the y-coordinate at the very top, which would be 3. Number 17, the absolute minimum would be, do you know, what's the lowest y value? 0. The absolute max, well, look at the graph, right? It goes up forever at that asymptote. It goes to infinity. Therefore, the absolute maximum does not exist because it's going to infinity. Number 18, the absolute minimum again is 0. And the absolute max again does not exist because of the hole. So notice the y-coordinate at the very top is a hole, so it's approaching a hole. So there is no absolute y-coordinate that exists right there. And so because of the hole, it doesn't exist. The other one, because of the asymptote, it doesn't exist. And then number 19, the absolute minimum again is 0. And the absolute maximum there is 2. So let's just double check to make sure I'm okay. Oh, let's lower this down. So for 16 and on, so 0, 3, 0 doesn't exist, 0 doesn't exist, 0, 2. Perfect. All right, let's keep going. Now to do with the mean value theorem. So the mean value theorem, and I'm going to write it down and show you my work, is when A rock equals I rock. So the mean value theorem says there's two conditions that have to be met. So one, it has to be continuous, and second, it has to be differentiable. And in the interval, if it's continuous and differentiable, then there has to at least exist one moment where the instantaneous and the average must be equal to each other. There could be more than one moment, but there has to be at least one moment. So that's what the mean value theorem is. It's when A rock equals I rock. It only exists when it's continuous and differentiable. So let's look at both those things. So number 20. F of x equals the absolute value of x from -1 to 3. So from -1 to 3, it has to be continuous and it has to be differentiable. So absolute value is a v, that is continuous everywhere. But there is one exact point where you can't take the derivative. That would be the vertex where there's a sharp corner. So for the absolute value of x, it is not differentiable at 0. And is 0 in my interval between -1 and 3? The answer is yes. So MVT does not apply. I'm going to show you this. So the MVT does not apply So why again is it not differentiable? Because of that sharp corner. Let's just make sure we're doing okay with these. Oh, let's do this. There it is. So number 20 does not apply because it is not differentiable at 0. Wonderful. All right, next one. 21. So we have a function. X squared subtract 2x from 1 to 3. So the first thing I look at is it continuous from 1 to 3? Yes, it's continuous everywhere. It's a parabola. Next I look at, is it differentiable? Is there any spot where you couldn't take the derivative? And the answer is no. It is absolutely continuous and differentiable. So one way to tell that is to take the derivative and actually see it. So x squared subtract 2x. Is there any x value there that would make it undefined? No. Take the derivative, which is 2x subtract 2. Show this. Again, are there any x values here that would make this undefined? So you could think of it algebraically as well. Is there any place that would be undefined here? No. It's continuous. It's differentiable. Therefore, from 1 to 3, A rock can equal I rock somewhere. So let's do the work then. All right, for this one, let me just double check here. So yes, find the C value. So here we go. So in order to do that, I already found the I rock. That's 2x subtract 2. It's at 2. But I haven't found the A rock. So to find the average rate of change, it is the difference quotient. So the denominator, 3 take away 1. The numerator, f at 3 subtract f at 1. So there's the slope formula or difference quotient. That's the A rock I need to find right now. So I'm going to plug 3 in. That's 9 take away 6. That's 3. Plug 1 in. That's 1 take away 2. Negative 1. So when you subtract a negative, you're adding. So it's 4 divided by 2, which equals 2. So take the derivative equal to the A rock, which is 2, and then solve it. So I'm going to add 2. That's 4. Divide. So it asks for the C value of where it's true, and the answer is 2. Sure here. And there's our answer. That should say A rock. Needs a little O there. All right, number 23. So for number 23, we kind of need to know what this looks like. This is a unique looking function, and it's from -2 to +2. All right, so for this one, do you know what that looks like? And so I'm going to help you out through this. Now, if I didn't know what it looked like, first thing I would look at is it continuous. So could I put a negative number in for x and get an answer? And the answer is yes. You can square a negative number, cube root it, it's fine, including 0. What happens when I take the derivative of this? So that would mean that you would have 2/3 times 1, but 2 take away 3 gives you -1/3. In other words, this is what you end up with. So that 1/3 is a cube root. There's an issue here. So where is it undefined? So at x equals 0, the derivative does not exist. So because, is that here in my interval? Yes. So because the derivative doesn't exist in the interval, there is no C value to find. 24. Is f at x equals, but a different interval. So an f at x equals x to the 2/3, but now it goes from 0 to 1. So again, I said at 0 it doesn't exist, but technically because it's at the end of it, something between 0 and 1 could exist. So a little bit challenging there that 0 is part of the interval, but there is something. It is continuous and it's fine from 0 to 1. So when you take the derivative, remember it was 2/3 x to the -1/3. If I find the difference quotient or the A rock or the slope formula, 1 take away 0, and then f at 1 subtract f at 0. So 1 to any exponent, 0 to any exponent. You can see the average rate of change is 1. So if I make this equal to 1, could you solve it? So the first thing I would do is multiply both sides by 3/2. And then the next thing I would do is raise the exponent that would undo -1/3. So the exponent -3 undoes -1/3. So the negative times the negative makes it positive 1/3 and 3. That gives me x to the +1 exponent, or just x. Now what does this mean? Well, 3 times 3 times 3 is 27, but it goes in the denominator because of the negative exponent. 2 times 2 times 2, that's 8. And that, I believe, is your C value between 0 and 1, where A rock equals I rock. Let me just check. So notice for 24 that it applies, and we did the work to get 8/27. Oh, what am I doing here? I'm trying to get to that one. Next one. Where are we at? 25. So for number 25, you have f at x equals, and you have 1 over x subtract 4 from 2 to 6. So what are the two things we're looking at again? First of all, is this continuous? Well, no. What x value is it not continuous? So if I look at this, look at the denominator. Can you think of what x value? So at x equals 4. Why? Because 4 take away 4 means it's 0 in the denominator, right? So because of that, at x equals 4, it's not continuous. There's actually an asymptote there. Next thing I look at, is that actually in between 2 and 6? Yes. So what just happened? So the MVT does not apply. Why? Because at x equals 4, f at x is not differentiable. No, it's not differential and not continuous. So if it's not continuous, it also means it's not differentiable. But it's really continuity. If it's not continuous, then this follows. So it's okay to write both. But this is the big one. It's not continuous, and that's in the middle of my interval. 26. F at x equals x squared subtract x over x. Now, and this is from -1 to +1. Now, if I look at this, before I simplify this down, can you tell that it's not continuous at an x value? So the denominator at x equals 0, it is not continuous, or there is a discontinuity. Is that in the middle of that interval? Yes. Now, if that wasn't in my interval, then you could keep doing the work. But it's over. MVT does not apply. Why doesn't it apply? That's why. Because at x equals 0, it is not continuous. All right, make sure that we're doing okay. Check the answer key. So for 25 and 26, it doesn't apply because of continuity. Again, it doesn't apply because of continuity at 0. Wow. Beautiful. Here we go. Oh, let me then minimize that. So now we're at our last one, 27. The nice thing is when you see it's a polynomial, it is then continuous and differentiable everywhere. So I recognize it. Parabola, line, anything that's a polynomial, that means whole numbers in the exponents. That means that it is going to apply and that it's continuous and differentiable. So let's do that. So x squared subtract 2x from 0 to 2. So step 1 or 2, I need to take the derivative. That's 2x subtract 2. I need to find the difference quotient, or the AROC. That is f at 2 subtract f at 0, 2 take away 0. Just do the work. 4 take away 4 is 0. If I plug in 0, it's 0. So do all the work and the answer is 0. So the derivative equal to 0 and solve it. I'm going to add 2. I'm going to divide by 2. So what is the C value that guarantees it? So if you have a C value of 1, then the MVT applies. So the mean value theorem at its core is AROC equals IROC. So you take the derivative, you find the slope formula and use that, make them equal to each other and solve it. But before I do that, I need to know, is it continuous and is it differentiable? Make sure we did this one correctly. Oh, try again. So there's the answer key. So when I'm looking here at the answer key for 27, that's the next page. So it does apply, you solve it, and we got the C value to be 1. Beautiful. All right, next one. Find the C value guaranteed by the mean value theorem for the given function on the given interval, and you may use a calculator for this. That's nice of them. So f at x equals x cubed subtract 2x squared plus 3 from -1 to 2. So we are going to use our calculator. Let me show you what I would do. So write it down. First step is it's a polynomial. Beautiful. Poly means it is differentiable and continuous, and it meets the conditions, so I don't have to overthink about it. So I see the positive whole numbers for exponents. It's ready to go. Next, I need to take the derivative and make it equal to the slope formula or difference quotient. So in this case, it would be f at 2 subtract f at -1. And then in the denominator would be 2 subtract -1. So there is the setup. I'm going to let the calculator do the work. So how would I handle this efficiently as possible? Well, this is what I would do. So I would go menu, and then I would go algebra, and then I would solve it, because I'm solving an equation. I need to know the derivative. So menu, calculus, derivative, and not derivative at a point, just the derivative. And it's the derivative of x cubed subtract x squared, 2x squared, plus 3. Move the cursor just over 1. Make sure it's still inside the other parentheses. And now I'm going to do a fraction line. So control and then divide gives you that fraction line. So now I'm going to plug 2 in. So that's 2 cubed subtract 2 squared plus 3 subtract. In fact, I want to show you even a faster way to do this. Let me just do that, because I'm going to realize I don't want to do this. So let's do this. I want to go back. I want to press the toggle button for the calculator to go to the graph, and I'm going to go tab, and then I'm going to go back to F1. Oops, there. And I'm just going to erase that. And in my calculator for F1 at x, I'm just going to define it as x cubed subtract 2x squared plus 3. So I'm then going to press enter. And what I'm doing that is I am now defining it in my calculator where I can use that definition, not have to type so much. So F1 at x is now defined in my calculator. So let's do that. So the shaky calculator. So I'm going to solve this. So let's see here. So again, we're going to go menu. I'm going to go algebra, and I'm going to go solve. And then I'm going to go menu, and I'm going to go calculus. I'm going to go derivative. So we want to find the derivative with respect to x. And we've defined this so I don't have to type it in. So that's F1 at x. So there it is. Move the cursor just over 1 equals control divide. Now we can type it in our calculator a lot easier. So we're going to go F1 parentheses, and it's 2 subtract F1 parentheses -1. And then in the denominator, it's 2 subtract -1. And then what I need to make sure I do at the end of the fraction is then go comma x. So I'm solving for x. So I defined it in my calculator first. Then I can set up that equation, which is IROC equals AROC, and then go control enter. Now, in this example, you get 2 answers. Now, there is an interval here, and we have to see if they both fit in our interval. So one answer is, so I move this, is -0.215. Another answer is 1.548. Now, when I look at that, they both look like they're inside that interval. So I have the answer I'm looking for. Let's just double check to make sure I did it correctly. So this is for number 28. So -2.15, 1.548. Perfect. All right, let's try that again, and let's do the short way from the beginning, shall we? So, number 29. We have f at x equals 1 over x subtract 1 from 2 to 3. So I want you to notice, first of all, this is a rational, so look at the denominator. What makes the denominator equal to 0? So at x equals 1, it is not continuous. Now, I look, is 1 inside my interval? And the answer is no. So it is continuous from 2 to 3. If 1 was in the middle of the interval, then you could not do this. But we're fine. Because the one number we need to be worried about is not in our interval, we can then do the mean value theorem. And so I'm going to set this up. So it's the derivative equal to, and in this case it's f at 3 subtract f at 2, and then we know 3 take away 2 is 1. So that's the setup I'm going to use. And again, I'm going to use my calculator, and we're going to practice that shorter way to be able to do this together. So already in my calculator, I need to first redefine this one. So press that shaky calculator button to get back to the graph. Press tab, and then go back to f1. So I'm going to erase that. So that was my old f1 at x. I'm going to redefine it. I'm going to go control divide, and I'm going to put in 1 over x subtract 1. So if you need to press pause, you can, but I'm going to redefine it, press enter. So now in my calculator, it's been defined. Then I press that shaky calculator toggle button again, and I'm going to do this. So you know what? It's almost set up here, isn't it? So I'm going to press enter, and then, so I went back up, highlight, press enter. The left part is perfect, right? Exactly what I want, and I redefined it. This one here needs to be 3 and 2, and that's it. So 3, 2, oops, 2, there it is. The denominator, 3 take away 2. And if I already have that template up, why not just highlight, make it, put it down below, and then edit it, control enter, and then you can have your answer. So I got 0.414, negative 0.414, and 2.414. So the question is, why am I going to cross out one of these answers? So again, here it is. Those are the two answers. Yet, I'm going to cross this one out. Why? Well, look at the interval. Is negative 0.414 in the interval from 2 to 3? No. So what's the only x coordinate, which then becomes the c value they're looking for, that is in my interval? And what's happening there? At that one, the average rate of change is equaling the instantaneous rate of change at that number. Awesome. All right, let's just double check, make sure. There it is. And notice that the only one in the value in the interval is 2.414. And because we could use your calculator, see how much fun things we saved that you'd have to do if you didn't have your calculator, right? Thank goodness for the Nspire. And yes, you can use it on the AP exam if you're allowed to use a calculator. All right, let's finish this. So we have one more question. Darn it, right? And then you're done. Yay. So number 30, the height in feet of an object at time t is given by that. So I'm going to write that down. H equals negative t squared, negative 16t squared, plus 200. And then it tells me to find the average rate of change, or the average velocity, I should say, of the object during the first 3 seconds. And then use the mean value theorem to find the time at which the object's instantaneous velocity equals this average velocity. So let's break this down. And it's from during the first 3 seconds. So that's 0 to 3. All right, let's do this. So first of all, I need to find the velocity. So what I'm given here is the position. The height is a position of what it is. So to find the velocity, I need to take the derivative. So the derivative of that, 2 times negative 16, subtract 1 from the exponent, is negative 32t. The derivative of 200, of course, is 0. And it says find this. Using this, right, we're going to find that I rock versus A rock. So if I was looking for A rock, I would find that as the average. So plug in 3 and plug in 0. Well, if I plug in 3, I'm actually not going to simplify it. I know when I plug in 0, it's 0. And the reason I didn't simplify it is because the 3's divide out and give me negative 32. And then the next question is, so that's the average velocity. And do we have units? Probably feet or something, right? I have to go back to this. Feet and seconds. So that's negative 32 feet per second. So over the first 3 seconds, that is the average velocity. That's A. It says use the mean value theorem to find the time at which the object's instantaneous velocity equals this average velocity. So I think, I don't want to lead you astray here, but if we take the velocity negative 32t and make it equal to the average velocity negative 32 and solve it, you can see at 1 second the instantaneous velocity is equal to the average velocity. So at 1 second it's negative 32, and the average over the first 3 seconds is also negative 32. So that's what I got. I'm going to check to make sure we're okay. So the average velocity over the, this is part B. So at t equals 1 second, the average velocity from 0 to 3 is equal to the instantaneous. And I don't need to write it because I already said it at the beginning. It's right there. Period. To the instantaneous velocity. So let's make sure we're right, and then we're done. What is it? There it is. So, oh, what did I do wrong? So the average velocity is the slope of that. So I totally, right? So instead of doing that, so what I actually found when I took the velocity and did that was actually the average acceleration. That's why we check, right? And then understand what I did wrong. So the average velocity is simply doing the difference quotient with the position. That's a mistake I made. So let's make sure and go back and correct that. So let's do A over again right here. So this is what I should have done to find the average velocity. That's the slope from 0 to 3 using the position. I get it. So when I plug in 3, negative 16, and then 3 squared plus 200, subtract, plug in 0, and I get 200. And that's all over 3. Because I want to do this without a calculator. I understand that 200, take away 200, we're done. I also understand this, that 3 squared and 3, the 3 goes into this to make that only 1 3. See, by simplifying it, if you didn't have a calculator, you can make this a lot simpler and see that answer is negative 48 feet per second. That's the average velocity. And then we already took, so part B is wrong there. So obviously this part is right. That's the instantaneous velocity. We're going to make it equal to negative 48. And when you solve for t, you divide. So negative divided by negative, that's positive. 48 over 32 is a great answer. But if you really care, you could divide by 16, top and bottom, and get that. So then we can change this sentence at 1.5 seconds. So at 1.5 seconds, the average velocity from 0 to 3 is equal to the instantaneous velocity. So it's good to check your work and then understand. It's not making the mistake, it's understanding the mistake, right? And growing from the mistake. Mr. G Math, over and out. I'm so proud of you that you're doing your work, and continue to do your work, and until next time.